Hey everybody, welcome back to some more live coding. Today we're going to be talking about the Crystal programming language. The Crystal programming language is an interesting one. So it is relatively new, coming out. First appeared 4 years ago in 2014. And the big thing about Crystal is it's supposed to be compiled and as fast as C, yet have the syntax of Ruby. So here we go. This is what it looks like to write an HTTP server. I'm on their homepage right now. This is just crystal-lang.org. NullPixel did it. I was watching some of John Hammond's stream earlier, and I had to cut out, but that's funny. I actually didn't do that on purpose, but I was just late tonight. So Crystal is supposed to be Ruby with C, but like C. Okay, so it's supposed to compile and be super fast, yet you don't have to write the nasty syntax of C. You can write it like this. And it's supposed to be not exactly compatible with Ruby, but it's supposed to be just like Ruby. Like, it's based on it completely, and that's what it's all about. So we're going to look at, here's the agenda over here. We're basically going to look at, so what is it? It's compiled, but with the syntax of Ruby. Basically, it would be an alternative to, in my case, from my limited understanding, I would use this if I wanted something that was performant, but I didn't want to have to write some yucky C code. So maybe, and we'll explore these. You can write web applications and stuff with it too. So anything that needs high performance, basically. Install and compile the Hello World. Yeah, so let's do this. So let's check out the install. And on Debian and Ubuntu, they want you to install their keys and add their apt repos. So I'm going to do from atar gzip. Yeah, I just want to, let's see, download the latest release. 0.27.2. Okay, where's the file? Oh, here it is. I want the Linux x86 64 tar. Oh, there's a deb. No, I'll use the deb. I'll just download the deb directly. That'll be the easiest way. So the .deb is a Debian package. It looks like they have an RPM too. And the package, I guess, is the Mac one. Okay, so now that we've got the deb, we can just do sudo dpackage-i on the Crystal deb. Okay. Oh, there was an error. Oh, I guess it needs some dependencies. Sudo apt install live event dev. Done. Is that enough? Or is there going to be more missing dependencies? What? I thought I just installed that. However, package live event dev is not installed. Can I just do apt install on the dev package? No, it doesn't look like it likes that at all. What is it complaining about? However, package live event devs. Apt install live event dev. Now, did that work or not? To correct these, but it is not going to be installed. Yeah, let's install their dependencies too. Okay, how about live event? Oh wait, we'll do extra live event pthreads, live event OpenSSL. Is that going to be good enough? Do I have to do each one? Now hold on a second. This is already, I'm going to actually try and download the zip too. I'm going to see if that one works any better. So if I just download the gzip and I extract it, so we say tar extract zip file crystal.tar.gz. Now we should have a docs. Oh, that was just the docs. Here it is. I needed the x86-64 tar.gz. Oh no, okay, now I need tar extract zip file crystal 2-1 Linux. Alright. Now let's see if we can just go in there and run it. So there's a bin directory in Crystal. Yeah, there we go. Okay, so what I'm going to do is the bin here, print the working directory. I'm going to take that and I'm going to add it to the end of my path. And now we should have Crystal available as a command. Okay, good. So now we installed it. Actually, what I'm going to do is pop open my cookbook repository. Oh, I've got a lot of stuff. I'll just VS Code here. I'm going to create a folder for Crystal so we can track some notes. I'm just going to new directory Crystal, new file readme, and I just want to make a note about how I installed it. So we downloaded, oof, I need to make this bigger. There we go. So we downloaded the tar gzip from the releases, extracted, added, bin to path. Okay. So now we did that. How about the compiler? So I guess Crystal is the compiler. It's init, build, end, eval, play. Okay, so this is kind of like the master tool chain. We can init a project, we can build, we can generate documentation. That's interesting. We can print environment information. Okay, what I'm going to do is alias C equals Crystal. Yeah, just to save me a little time here. So cn is going to say there's a cache directory, Crystal path, Crystal version. Okay, so starts Crystal playground server, and it's got a run as well. So kind of like Go, it's got a run command where you can build and compile and run it. And specs, I figured out the other day, was that's what these are calling. They call them tests. Specs, I guess, they're related to unit tests, but for the behavior-driven development style. So they're like unit tests, but they're just described differently. And TypeScript uses that too. So I think that's just like a way of unit testing. So I want to see this playground. Wow. That's baked right into... Oh, connection lost. Okay. So this is just like the Go playground. Yeah, it died. Cannot find -L event. Oh, this means you need to install sudo apt install. Do I just need to install live event first? Now I tried this earlier. Do I just need to like install each one? Sudo apt install. Okay, that one, and that one, and that one. Apt dash dash fix broken. I don't get it. You tell me to run fix broken, but that doesn't fix anything broken. There we go. I think I got it. I just had to do all of them together with the fix broken. Okay. So now will it let me play in the playground? Oh, Mythic says hey and good night. Well, hey, thanks for stopping by. Yeah, it hasn't crashed yet, so this is a good sign. Okay. Connection loss refresh, no problem. So this is actually pretty slick, happy crystaling. And so this is like... Oh, interesting. So if you have a playground folder, you can store all of your stuff. I'm not sure how the workbook works. So we can run it. Let's hit run. Oh, this is the output. Or is this... No, this is like a debug info on the right. Those aren't print statements. That's actually like debug information. That's interesting. So how do you save, show output? Okay, so the output actually shows down at the bottom if you click that. You can run the formatter. It's running. Oh, here we go. Download code as file, share as gist. Download code as file. Okay, let's save that into just a directory called playground. And then let's run. Yeah, okay, so I'm still in my home directory and I got the playground there. So now if I go to the workbook, yeah, interesting. So if I go into the playground directory, like let's copy play and call it hello. So now we've got two files in our workbook directory, or playground directory. And if we go here, yeah, they show up. So it's like you don't even need an IDE to get started. You can get started and run and do everything kind of right here. And it's still on your computer, which is cool. So that's pretty neat. I like that. About Crystal Playground is developed together with Crystal Compiler. You can find the source here. Okay, so it's right in the core language repository under tools. So it's very baked in to the language. Well, it's very, I guess, well supported by the language is a better way to say it. Oh, and look, you can even embed a whole bunch of them into one page. That looks really nice for sharing code and learning, and for practicing and learning and stuff, so that's really neat. That's a nice feature, but not really what I was looking for, I guess. So, okay, we figured out how to install it and do all that, so... let's see. Now, let's try, so basically you had the C build, so right, if we just tried like hello dot, what did they call it, .cr, and I guess I will go inside my cookbook crystal directory, and we'll try vim, well let's inside our crystal directory, let's make a playground, and then we can say in here, we'll say vim hello.cr, and just puts hello world. I mean, this is just Ruby syntax, right? So I shouldn't have to think much about learning new syntax. So then we can say C build hello.cr, unterminated character. Oh, am I supposed to use double quotes? There we go. So now it's built. It built really quick. It's interesting. So the hello world is 1.1 megabytes. Quite relatively large, you could say. Like if you were compiling a C hello world, I'm just curious what that would be. So what am I doing? What's the standard one to get printf? Standard IO. Yep, someone will probably correct me in a second. Int main. Int argc. Okay, so what is a hello world in C? Oh, yeah, there it is. Okay, so both of them work. Great. Oh yeah. Yeah, the size difference is quite big. But I guess it is fair because it's got a garbage collector, right? So what about what if we did a Go one? That would be a little more. Thanks, guys. I appreciate the help. Yeah, it's standard IOH. Package main, func main. I'm just curious what a Go one would be like, because they've got a garbage collector in Go, and I'm gonna have to do import funct, and then I can say go build hello.go. Oh, that one probably overwrote. Move hello go to hello go. Okay, go build hello go.go, and we'll say crystal build hello.crystal. Okay. So let's see, we've got 8.2K for the C one, 1.1 megabyte for the crystal one, and 2 megabytes for the Go one. So that's okay. I was just kind of curious. That's really negligible anyway. Do a Rust one. Can I compile just a single Rust file? Actually, I've got a Rust. Yeah, I've got a Rust Hello World here. So if I go into Target, oh, this is a debug one too. So that may not be a fair comparison because it's a debug one. But the Rust one is 256K. Okay, so 256K for the Rust one. So the Rust one is bigger than C but smaller than this one. And that makes sense because Rust doesn't have a garbage compiler or a collector, right? No, it doesn't, does it? And then, yeah, so the Go one's even bigger. It's all really negligible. It's not 100 megabytes, it's not 20 megabytes. 2 megabytes is... And as you get bigger, it's not going to get hugely bigger from there. That's just kind of the major dependencies. And I guess if you do... Okay, so yeah, actually what another interesting thing is that the Go one is statically compiled, right? So it doesn't actually link off to anything. It's got everything it needs inside of it. The Crystal one actually links off to all of these. Now I wonder if you can compile Crystal static, and that it says okay, add static c build hello.cr -- static. Uh-oh. Okay, those are just warnings. Oh, look at it now. Now it's 2.9 megabytes. So when you static compile everything, now if we do LDD hello, now there's nothing dynamic linked to it. Before it was linking to, yeah, live pthread, live event, live DL, live GCC, live C. All of those combined, now it's about 3 megabytes. So the C1 too, like if we had to link that to the file, it'd probably be bigger too, but even then, 2.9 megabytes, static flag, easy to compile with the static flag. I'm happy with that. Compile a file. Ooh. Okay, we're gonna say crystal build, and also static. Okay. And then just to confirm, we can do crystal run hello.cr, and it just builds and runs it. And that, you know, it happens pretty fast. Less than a second to do all that. Oops. Okay. So, cool. Good stuff so far. Now, let's explore the language itself. Now, this is, okay, so this is the syntax and the semantics, so I'm not going to go through all these, but I am going to high-level skim through them. So we've got comments, yeah, okay, just like Ruby. This is supposed to be just like Ruby, so shouldn't really be any big surprises here. Okay, so here's the types. Int 8, uints up to 64s. Floats, characters, strings, symbols, just like Ruby. Good, cool. Array, as expected. Hash, as expected. Range, yep, just like Ruby, very good. Regular expressions. Now I wonder what formats using PCRE syntax, because not all regular expressions are created equally. There are actually several different styles of regular expressions. Okay, so PCRE is the Perl one. I didn't know that's what it stood for, but yeah, Perl is the one that's probably the most common. And then there's like the grep one, which I think is slightly different, but for the most part, if you do Perl compatible, that's quote-unquote the normal, basically what you're used to. Okay, so regex is... What I like is that it's built right into the language. It's not like you have to call regular expression dot compile, and then you have to call regular expression dot search with your compiled search and this. It's first-class citizen like it is in Perl. You just, you know, you just use it. You just use it right in the language. Tuples. Okay, name tuples. Proc, that's the process. Represents a function pointer with the proc literal. Okay, commands. Yeah, this is actually one of my favorite things about Ruby. And it's the reason I like Ruby for shell scripting. If I need to write a bash script, but it's going to be complicated, the syntax for bash is really gross if you're doing anything besides just running shell commands. So if you actually need to write a shell script, now I'm going to go into the IRB, this is the Ruby interpreter. So basically you can just do backticks and then run any shell command you want. Oops, yeah. So what's cool about that is you can just do something like this and then take the output and then start running it through Ruby. What is it? Whatever it is. But yeah, so now you've got a list, and then you can do something like for each. You know, so it makes working, doing enhanced shell scripts much better, where you need to dip down into the shell scripts a lot to run commands, but you want to work with the output and you want to have some better logic around it. So they support that too, which is awesome. And this is a special character, just like in Bash. If you want to check if the last command was successful or not, then you can check that, and so you can actually check success. And another cool thing about Ruby is that you can actually have question mark and exclamation point as part of your function name or your variable. So it becomes a bit more intuitive when you can say, like, instead of just saying .success, you can say .success, and it's a little more clear, like, okay, I'm probably going to get back a bool. Security concerns. Oh yeah, you want to be careful about running shell commands. Okay, process.wait. Okay, so it looks like you can create a sub-process here too, process new. And you can tell it to redirect the pipe and do all that good stuff. So that's kind of like the long form way of doing this. Okay, local variables, control expressions, yeah. So I'm going off the assumption that people know Ruby already. So I'm not going to dive into like, oh, well, this is how this is how you check a type, because there's lots of information on Ruby and stuff out there, and I'm just assuming people know that much. Okay, so requiring files. Yeah, this is one thing I was interested, was how do you break it up into multiple files? And actually it looks like they do it just like Ruby. You just do require. Lib. Yeah, so you just... Oh, okay. That's I thought for some reason I felt like that was going to be a more complicated thing. But it's quite literally just like importing a Ruby. It's really kind of mind-blowing how similar to Ruby it is. It's basically like, hey, you can write Ruby, but you can compile it, and it's going to be multi-threaded. That's one big problem in Ruby, and Python actually, is the GIL, the global interpreter lock, that only lets you use maximally one CPU worth of power, unless you multi-process. Okay, types and methods, everything's an object, yeah. Just curious, who out there is a fan of Ruby or uses Ruby? And Vladimir's talking about VLang. Sorry, I was missing your messages earlier. You're saying there's a new version of Go called V with smaller binaries. Well, honestly, the size of the binaries is not a big deal. I mean, if we're talking about 2 megabytes difference between like a megabyte or 2 megabytes, I personally don't care at all. I don't care at all if the hello world statically compiled is a megabyte different. I care if we're talking about a Java application with the JRE embedded in it, and you're talking about 200 megabytes. That makes a pretty big difference. Now, I can understand if you're doing a lot of cloud stuff with Docker containers, and like those little bits really do matter. But vlang.io. Okay, let me pull that up real quick. Hopefully that's actually a language site. So, whoa, this isn't Go. This looks nothing like Go. You tricked me. You said there is a new version of Go called V. I guess maybe you're just saying like it's a compiled language. This looks more like something else. I can see like, okay, this operator that Go borrowed from Pascal is now being borrowed again here. But other than that, it really doesn't look... It doesn't look that much like Go. I mean, it kind of does, but either way, most of the languages are similar enough. Yeah, classes, class person. This is actually really cool because it's like you don't really have to learn anything else. It's like, if you know Ruby, you're good to go. I think I might try to start using this out some more. Now, it is not the most mature language, but I do want to show... it looks like they really have all the support for all the core stuff. But, okay, so if we go down to the bottom, you can do cross-compiling. So, yeah, with cross-compiling, all you have to do is give it the target. But I wonder if I can list what targets I have available. Was that in my env? No. Spec, run a tool, help. Default target. So let's see. Crystal lang list targets. No, this is the same page. Interesting, yeah. Then they don't have a list here of what targets they support. The LLVM target triple. Oh, so are these the targets that it supports? I guess anything that LLVM supports, it supports. LLVM target support. Vladimir says, V is very similar to Go. I am not spamming, I swear. No, I did think you were spamming. I just, when I saw it, the first thing I thought was not, oh, this looks like Go. But, okay, so you pointed me to a comparison. A comparison to Go. V is very similar to Go. No global state. Declaration style, no null, no undefined. Immutability, no runtime. Much smaller binary, zero cost C interrupt. No garbage collector. Go does have a garbage collector, though. And these are the things it approves upon. I see. So they're saying it does. The V doesn't have a garbage collector, and it does have generics, which was a big complaint about people in Go. Okay, cool. Hey, well, thanks for that tip. You know, maybe I'll check out that language later. Let me write that down. Cool. So I'm not gonna look at it anymore right now, but maybe in another stream I'll dive in and start exploring it. So I guess, yeah, LLVM compile targets. I'll have to check more on that, because this help file here isn't. I wish it would give me maybe a list of options and a couple examples, but I don't see them. So okay, we explored. It looks like you can if you have the right target. Not sure which targets they use, but one thing I wanted to see was crystal language, and they have, yeah, so the API. The API is basically what they call their standard language, standard library. And they've got some nice badges. Build passing, circle CI passing, chat on Gitter. Okay. Yeah, why? We love Ruby's efficiency for writing code. We love C's efficiency for running code. We want both, full OOP. Okay, now if we look on the left, this is a list of all of their standard library packages. So I'm not going to look at all of them, but we've got arrays, base 64, big decimal, big floats, big arrays, bools, box. What's a box? A box allows turning any object into a void and back. Interesting, so it's like a black box. A box's purpose is passing data to C as a void and then converting that back to the original data type. Yeah, I probably won't use that much. Bytes, channels. Channels are nice. That's kind of like in Go. They've got channels. It's a way to talk between processes. They've got buffered, unbuffered, chars, chars. Colorize. That's pretty cool. So they've got an ANSI escape code package built in. Colorize, I think, is the same one I've used in Ruby before. Now, I think. Colorize. No, I've used it in... No, it's called Colorama in Python. There is one, I think, called Colorize for Ruby. Yeah, so it's the same one, so you can even... That's cool. Yeah, you just say colorize green or dot colorize red or whatever. You've got foreground and background. Yeah, just typical ANSI escape codes. You've probably got clear screen codes and stuff in there too. Concurrency? Okay. Not much there, actually. There's crypto, bcrypt, blowfish, and subtle. Okay, I don't see any AES, anything like that. Not in there, not in that section at least. CSVs, looks like you can do comma-separated spreadsheets. Digest, okay, that's some hashing. You got MD5 and SHA-1, that's it. A little light on the crypto, but I mean, look, they call it 0.27, so it's fair that it's not all there. But I do want to see what is there. There's file, floats, gzip, garbage collector, hashing, HTML. Oh, for escaping and unescaping, that's good. So some security things there. There's HTTP. Oh, they've got relatively mature HTTP library. They've even got WebSockets, servers, requests, headers, handlers, cookies, clients. Okay, so actually they've got pretty good HTTP support. Now I wonder, like, let's pull open the client. Oh, nice, good. They've got some good examples right there. Let me try this one. We're going to try http client.cr. We'll pop it in, and why don't we try pulling Dev Dungeon? Okay, so now we'll try crun HTTP client. Uh-oh. Did it... I guess I gotta say puts response.body. .lines? Sure. Okay, so now if we run it, it should actually print something out. There we go. And it works. So just like that, we were able to compile. Actually, I wonder how big that one is too. Oh, I didn't see build HTTP client. And so that one came out to 2.2 megabytes. And if we build it static, oh, those are just warnings. But yeah, I probably wouldn't statically compile. But let's see, 6.5 megabytes. Okay. And yeah, it just looks all like Ruby, so there's really nothing surprising there. IO JSON, it looks like it's got JSON support too. Okay, you can parse it, and you can build it, and you can generate 2 JSON. Alright, so JSON and HTTP, looks like we're good to go on the web side for like 90% of things. LLVM, okay, ints, IO, IP socket, iterator, oh, yeah, I already did these. Loggers, Markdown. Interesting, it's got a Markdown library that will convert Markdown to HTML. Okay. Math, mime, mutex, numbers, OAuth. Oh, it's got an OAuth client. That's pretty fancy. Assuming you have an access token, you can set up an HTTP client to be authenticated with OAuth 2 using this code. Oh. Interesting. Okay, what else do they have? OpenSSL? Okay, well, OpenSSL support's really good because that means you can check certs, validate certs, connect with SSL, generate self-signed certs. Well, assuming you can generate the key, because their crypto libraries were kind of light. But OpenSSL should let you to generate an RSA key. Regex, sockets, strings, TCP server, TCP socket. So if we're comparing this to something like C, then the standard library has way more stuff than C does. It's more like Go out of the box, although Go has a much more mature standard library. rightfully so. It's older, it's more mature, and they even call it 1.0. They call this 0.2, so it's fair. But it looks like they've got quite a lot of this stuff already fleshed out, and you know, maybe I can find a case for using this. So let's see, what else do we have here? So we just explored the API. Yeah, the crypto looked kind of weak. The channels was kind of cool. It's nice they have a colorized library built in. The CSVs can be really useful too. So like, this is all just stuff that's in the... Oh yeah, they had stuff about databases in their documentation. It was at the very bottom. Database. To access a relational database, you will need a shard designed for the database server. The package CrystalDB offers a unified API across different drivers. SQLite, MySQL, and Postgres. Okay. I'd be pretty happy with just SQLite and MySQL for most of my use cases. Okay, so SQLite works. They've got a MySQL connector, very good, and the Postgres. So okay, basically I just wanted to make sure like they support it, and it looks like they've got those now. I am curious, like Crystal MongoDB, is there a third-party one out there? Okay, and it looks like there is. Not only is there just a simple bindings to the library, it looks like somebody's even created an ORM on top of it too. That's pretty cool. So here we go, awesome Crystal. Now this is the last thing I wanted to see, was packaging and sharing libraries. So if I wanted to package Crystal package library. Oh, they're called shards. That's what they meant by shards. I was wondering what they meant by shard. I thought they meant like a database shard. But they're talking about crystal shards. Hey, Pandals. Pandals says, trying new languages? Cool. How's Crystal doing so far? Is it meant for backend? Yes. Yes, it's meant for backend. It is a compiled language that claims to have the speed of C with the syntax of Ruby. So you can think of it as Ruby, but compiled. And that's really the gist of it. Okay, so crystal shards. Now I want to see, how do you actually package? How do you package? How do you get? Here we go, writing shards. The highs and lows of Crystal for 2017. Maybe someone will want to read that. Okay, dependency manager for the Crystal language, so shards. Oh, I do have it installed. Shards. Okay, so hold on, let me go back and check. It was in my downloads. Crystal bin. Okay, yeah, so there's two programs here. There's one called Crystal and there's one called Shards. So those are basically the only two programs that it put in my path. So I'm in Cookbook, Crystal. Okay, so Shards. Oh, I never tried out the init either. So if we do Crystal init, I wonder what it'll make. Oh, I need to give it the type. The type, a library or an app. Oh, well, I guess this is going to help me out. Let's try a library first. Okay, so let's open VS Code in this. Okay, so shard.yaml. I guess this is the equivalent of, this is the equivalent of the genspec or the setup.py. It basically defines all your metadata. Okay. Nice. It gives us a nice little readme. Oh, okay. It even tells us. Yeah. So let's look at the rendered side over here on the right. So, installation. Add the dependency to your shard.html. Okay, so this is how someone would add our project if we put it online. And then you just run shards install, and I guess it goes and fetches it and builds it. And then to include it, you just do that? Oh. Well then, that's incredibly easy. I'm basically just going to copy that. I want to put that in my other README. So that's compiling a file. Initializing a library or app is going to be done with crystal init. Crystal init lib my project or crystal init app my project. I guess we'll say my lib. And then yeah, so to let's say to package and share a module, push to GitHub with the what was that YAML? Shard.yaml. Okay. To add a package as a dependency in your project's shard.yaml. Dependency. Then tap that over. And then to require a dependency in the code, you just call the require. Okay. Well, okay. That should be good enough there. I just want to kind of jot these notes down. These are kind of the condensed, most important things of what I've learned so far. And just to recap, that is starting off with installing. We just downloaded the gzip, extracted the bin, and added the path. This adds crystal and shards to path. Okay, and then we can run the playground and start playing around and start saving files. We can compile files. Then we can compile and run files. And let's also mention that you can do a crystal run. And then you can initialize a project like this. And then once you've got a project initialized, you just fill it out, and then you put in your source here. Put your tests in here, I guess, if you have any. Yeah, this is like unit testing, but abstracted to be be English-like. So instead of saying like run this test and assert this, you say describe my project. It does. It works. Do false should equal true. Like it's called behavior-driven development instead of test-driven development. It's basically tests, but with a bunch of weird syntax. And that's a Ruby thing. Ruby's very big on testing. So, I mean, it basically just tells us what to do. So what if I want to build it and package it and push it up, and not just to GitHub, but I want to push it up to, okay, shard build, shard check, now, okay, so let's see, I want to do shards build, dependencies are satisfied, okay, I didn't ask you if the dependencies were, okay, so let's see, it built this bin directory, and there's nothing there. Okay, maybe it's because we need to actually do something. A function, def test, end. outputs hello. It looks like doesn't even have syntax highlighting. The marketplace has an extension that will help. Alright. Thank you, Faustino Aguilar. I will install your Crystal language plugin. And look at that, we've got syntax highlighting. I bet all it did was steal the Ruby syntax highlighting. Okay, so now if I run shards build, will it /shard.yaml? No, so shards build, but how come it's not putting anything in the bin directory? Do I need to tell it in my YAML file, like, hey, build the library of this? So let's go back real quick. Shards usage. Crystal applications or libraries are expected to have a shard YAML that looks like this. Dependencies, development dependencies, license. When libraries are installed from Git repositories, the repository is expected to have version tags. Okay, got it. Semantic versioning. Yeah, I like their versioning with the major numbers, with the three dots. 3 numbers, 2 dots. Shard is usually... Oh, so wait a second. This may be actually more like Go, where you actually don't package compiled files and push the packages up. Like with Go, you literally just put it on GitHub, and when someone wants to install it, you just put the GitHub path. You actually don't do like an npm install. You do a go get, but it pulls it from GitHub. So maybe that is all you do, is you just push it up as is, and there is no build step. But what was that? There's a build command, obviously, but a shard is usually distributed, shards itself is usually distributed with Crystal. Alternatively, a shards package may be available. Okay, so shards init will create a YAML. Shards install will install to your dependencies. Okay, let's see. Here we go, writing shards. What's a shard? Simply put, a shard is a package of Crystal code made to be shared and used by others. In this tutorial, we'll look at making a Crystal library. Okay, really, all I want to see is... Okay, yeah, Crystal init lib, and that creates your shard.yaml, which is like the real important one. Okay, we go in there, you write the code. Documentation. Document your code with comments, even the private methods. Crystal has a built-in documentation generator. Run Crystal docs to convert your code and comments into interlinking API documentation. And they even give you a badge. I don't know if you guys watched yesterday's stream, it was all about making documentation using read the docs and having read the docs automatically pull and generate your documentation. So let's see what format. Oh, Markdown. Crystal can generate documentation from comments using a subset of Markdown, which means it's very limited. To generate documentation, invoke Crystal docs. Okay, so basically they use doc strings that have Markdown. Got it. Got it. Comment with Markdown to generate the docs. I'm gonna add that documentation. Write doc strings with Markdown formatting to generate docs using Crystal docs. Boom. Okay. Oh, they've got a formatting tool? Nice to know. Okay, and now to push it, yeah, it's just saying create a repository with the same name and description as specified in the shard file. And then you push it, and that's it. So you don't have to build it. So if we go Here, I bet these are actually just links to GitHub repositories. And if we click on it, it really is. Okay, that makes more sense now. And look, this one right here is, oh, it's funny, all these are web frameworks. Kamal, fast, effective, simple web framework. Amber, a Crystal web framework. Lucky, a full-featured Crystal web framework. There's so many web frameworks. Kamal. Okay, cool. So yeah, it's a little micro framework. But that's cool because it's going to be fast and actually multi-threaded. A full-featured Crystal web framework that catches bugs for you. Yeah, so some of these actually look kind of nice. Amber, yeah, so there's no shortage of web frameworks anywhere you look. And this was the awesome Crystal language. Yeah, so this, hopefully this will kind of give us a real high-level view of some of the cool stuff out there. So, algorithms, API builders, blockchain, C bindings, caching, CLI builders, CLI utils, date formatters, database tools, development tools. I'm particularly interested in the development tools. Game development and GUI libraries, yeah, interested in seeing what those offer. Machine learning, yeah. Networking, routing, queues, messaging, scheduling, science and data, serverless, web frameworks, web servers. Okay, let's take a look at some of these. Development tools, Guardian, File Change Watcher, okay. File Change Watcher, File Change Watcher, File Change Watcher, File Change Watcher, File Change Watcher. Okay, so that's seems to be a very popular tool that lots of people like to make. Okay, game development, C-Ray, Cray, bindings for RayLib, SFML. That's a popular C++ library for writing games. So it looks like there's some Crystal bindings for SFML. That might be worth checking out. Chipmunk is a physics library. Yeah. Glove, never heard of that. That must be kind of unique to them. A collection of games using Glove. Mini offline single player game. GUI libraries. Okay, so there's a Qt binding, which is interesting. I wonder how mature that is. I like Qt as a framework a lot. LibUI, that's one I'm not familiar with actually. Simple and portable GUI in C. Uses native from each. Interesting. Yeah, I never heard of that one. Hedron. An extendable UI library in Crystal. Interesting. I wonder how they render the windows. Okay, a little unclear. It doesn't look very mature, to be honest. Lots of HTTP stuff. What else do we have here? I think we went through all of them pretty much. Serverless computing, yeah. Crystal OpenFaaS, that's FaaS is functions as a service. That's something that the cloud providers offer now, and that's, if you're not familiar with serverless, that's actually a really interesting concept. So at Amazon, they're called Lambdas, and it's basically you log in and you upload a single function that is an endpoint. It's basically like an HTTP endpoint, and you write the function, and anytime someone hits that endpoint, Amazon processes it, and you end up getting paid, or I'm sorry, you end up getting charged based off of how many milliseconds of execution time your endpoint runs. It's also called, at IBM Cloud, they're called what are they called? Cloud functions. So cloud functions are their equivalent of the Lambda, and it's built on OpenWhisk. And Google Cloud, I think, offers the same thing. I think they're called cloud functions on Google Cloud as well. Yeah. So they're really interesting. Event-drivenless, serverless computing. So you basically just create an endpoint, and you don't have to pay for a server that stays up 24/7. They just listen for the endpoint and run it when needed. So this is interesting. I wonder exactly how this works. Open fast. I wonder if that just means it helps you interact with Lambda or something like that. So writing shards, yeah, okay, so basically you run the generate and then you push it up to GitHub, and then when you add a dependency, you just add dependencies in the GitHub URL. So that's very cool, very straightforward. So that's it for the agenda for tonight. I really just wanted to explore what this language is all about, what kind of packages they have, how it looks, what the tool chain is like. So it's interesting. I'm gonna keep it in my pocket and think about cases where I might want to use it. Now, I use Ruby once in a while when I'm writing the shell scripts, and in those cases, performance isn't critical. So I wouldn't go from Ruby to Crystal. Where I would choose it is if I needed to write something that needed high performance. Like, if I was writing something in Python and it just wasn't cutting it, and I wanted to kind of port it to something compiled that was a bit faster, then maybe that would be a case for giving it a shot. Basically any time that I would reach for Go is a chance where I might say, is this a good case for Crystal? It would depend on a lot of things, like how stable do I need the project to be, and all of that, because basically Crystal is still kind of a not fully released. They call it version 0.27, okay? So I wouldn't use it for anything real serious, but I would give it a shot for exploring and doing certain things. So the last thing I'm going to do here is clean up my repository and push up some changes. So yeah, I'm going to remove my project since that doesn't do anything. And in the playground, yeah, I don't want to commit all of this stuff. Let's see, I'm going to remove all of it. There we go. C run hello. Yep, still works. Okay. And the real important stuff is all in that README. That's most of the important stuff that's important for me. Like, if I wanted to come back in a couple months, even a year or longer, and I wanted to say, oh, let's get a recap on Crystal. Where do I start? This is my cheat sheet. Oh, no, go away. I want to render it. How do I render it? There we go. So yeah, install it, how to run it, how to compile, how to build packages. Actually, I do want to say Crystal API. I want to put a link to this. Standard library. Documentation. So we'll just add a link to that. Well, I wonder if I can leave off that version so it always goes to the latest one. Yeah, let's do that. Okay. And why not actually leave a link to the language itself too? Okay, I think that's good enough for now. Let's go ahead and add crystal. So, you know, it's interesting that, like, we spent about an hour looking at this language, and I've barely written any actual code, which is kind of a neat thing because it's reusing all the Ruby syntax. So, like, that's one of the big selling features of the language is you don't have to learn a totally new syntax. If you're familiar with Ruby, then you're already ready to go. And I can see this being extra attractive to people who already do know Ruby because then they can start writing more performant applications without much work. Let me close that. Okay. Adding notes about Crystal language. Push. Alright, let's check it out and just make sure our GitHub repository got the changes. Let's see, where's Crystal? Oh, it just shows up under other. Well, I guess technically I literally have one line and it thinks it's probably Ruby. Okay, yeah, here we go. So we got a few notes. Awesome. Nim, Pandal says, do I have any plans on checking out Nim? And the answer is no, because I've never heard of it. So, not to say I won't now that I've heard of it, but I have never heard of it before. What is it? Nim. Nim is an efficient and expressive programming... Yeah, they all say that. Nim is a systems and applications programming language, statically typed and compiled. It provides unparalleled performance. Oh yeah, they all say that too. High performance garbage collected language. Compiles to C, C++, or JavaScript. Oh, so it doesn't even... I mean, it just compiles down to C? Produces dependency-free binaries. Or JavaScript. Awesome. Unparalleled performance in JavaScript. Statically typed and compiled unparalleled performance in JavaScript. Sorry, that just sounds so funny. I have to poke at it. Okay, I mean, interesting concept. Now, how and why is it faster? Why would I use it? Intuitive and clean syntax. Taking inspiration from multiple languages, the Nim syntax is easily understood and results in code that can be modified very effectively. Okay. Nice, because I'm always thinking to myself, man, this code is not modified very effectively. Like, how does the code become more easily modifiable? Indentation, significant syntax, multiple constructs, inspired by Python, multi-line lambdas, Oberon-inspired visibility markers, Pascal-inspired type sections. Yeah, I actually learned Pascal. I learned Pascal after I learned QBasic, but before I learned C++. And that was one thing about it. They had you had to declare all of the types and all of the variables in a section up at the top. You could not define variables in the logic section of the code. Okay. I might check it out. I jotted it down on my list. I might give it a shot and see what it's all about. So thank you for the suggestion, Pandals. And also, Vladimir, for the suggestion on the VLang. I will check that out too. Alright, I appreciate it, guys. Thanks for coming out, and I will see you all tomorrow. I'll do the quick plugs. Go to devdungeon.com and join us on Discord. There's a big button on the right column to join Discord. Also check out my book, Security with Go. subscribe to the YouTube channel so you can catch up on the daily streams, and go to github.com/devdungeon to check out all of the code to go with all the streams, and then some more. So thanks again, everybody. See you tomorrow.